Hello ladies and gentlemen, my name is Decryption and I hope you are well. I was recently on call with a client and they asked me my opinion on the way they'd done something. It was just some simple tweaks in Unreal and some code design. And I gave my honest opinion, as in I wouldn't use casting if I were you, I'd move to interfaces, it's a lot more memory efficient. And they portrayed back that they've never used them before, they thought it was really complicated, and it's not the first time I've heard this. Every time I speak to some form of Unreal artist, beginner programmer, somebody who's new to it or have never used it before, interfaces are the thing they always hear and they always not panic but get a bit worried about because it's one of those terms that sounds really complicated. And after I showed them and after I've showed many people how to use them, it just clicks and it's so easy. So in today's video we're going to explore blueprint interfaces in Unreal. We're going to break them down into their most absolute basics. We're going to look at multiple examples and we're going to show you how to check that they are actually working and how they work. So let's get started. So what is an interface? And this applies to not just Unreal, Blueprint, C++, many different programming languages have interfaces. I'd argue most programming languages have interfaces. So what actually are they? An interface, in short, is a way where you can access very specific portions of code on another object or class. That's it. That's all it does. Instead of accessing everything, you write a list of what they can access and that's all they can. Imagine going into a shop. You need to buy some chocolate, some milk, and some eggs. Do you need to know every single thing that that shop currently has in order to buy those things when you go into it? No, you absolutely don't. You just need to know that they've got the three things that you want. Can you imagine how much storage you'd have to have inside your head to remember every single product that that shop sells? And it's worse because it's not just the products that it sells, it's the packaging, it's the container, it's all the measurements of it. It's absolutely everything to do with that shop. You don't need to know all of that. You just need to know whether it's got your chocolate, your eggs, and your milk. Another example is when you go to board a train or a bus. Do you need to know every single person and all of their details when you get onto that train or bus? You need to know where they are, who they are, how old they are, all their properties that makes them there. No, you absolutely don't. And the same is in code. So let's take a look into it then. So this is my basic demo project here. All it is just I use for testing little bits of code here and there. And I have a pretty basic setup. I have my controller, I have my character, and I have an NPC here. For this demo, I have specifically used a metahumans one because they are naturally larger in size for their skeletal meshes and their materials, but this applies to everything, even low poly Cinti models. If I play a game here and I walk around, you can see it's just a top-down game. I can run up. If I press the E key, you can see it damages the NPC when I press E. So it buys a trigger, it gets that NPC, and it goes to it. So let's take a look then. So on my player controller here, when I press the E key, I get the player's pawn and I cast to it, and then I tell it to attack. Pretty common, that's what happens. Then on the attack method on my character, I simply generate a sphere overlap around me, which is a big sphere. I loop over all the people. I check if it's the NPC and I apply the damage. And then on the NPC, all I'm doing is printing I got hit. That's it. Now this is very common practice to do something like this where you need an actor, you cast to it. You see people do it in UI, attacking, everything, dialogue, anything you can mention, casting will be there. And casting is one of the biggest flaws to why people are a bit worried about interfaces because they're easy to do. You drag off, you cast, that's it, you've got access to everything. So if I jump into my NPC here, you can see I have every single thing in here. I don't need any of this to attack it. So if I come back to my character here and drag off this NPC, I can get his mustache. Why do I need his mustache when I'm attacking him? I absolutely don't need it. If you do need his mustache for some reason, give your code access to just a mustache. So let's take a look at why this is a problem, because we know it's tying it together and in theory it's bad, but we don't know why. So the key to find out why is the size map. So if I come to my content drawer and go to my controller here, if I right click and choose size map, this will show us all of the connections Unreal is making from this controller to every other asset. So the way this works is the biggest objects are the most memory intensive. They're the ones which take the most memory in proportion to everything else on the screen. So for instance, if I come to my input at my data asset for my input and choose size map, you can see they're still pretty big, but the actual size is 11 kilobytes because all it's doing is showing you in proportion proportion the size of everything. And 11 kilobytes is absolutely tiny. But if I do it again on my player controller, you can see it's 1.8 gig. So that means whenever this player controller is required to be in the game, which is all the time, it's going to try and take at least 1.8 gig of memory. And that's horrible. If you imagine having a game with 50 characters in it, that's nearly 100 gig. It's potentially going to want. But now we can see why it's a little bit bad. So if we look at the biggest ones here, you can see the sizes and what blueprints it goes to. So this is referencing my Quest here and my MPC. So you can see all the stuff that it's taking maximum size in. So down here, you can see my MPC is 1.6 gig. And then you can see if I hover over it, everything that's affected by it. So that's all of the mustache, the pose assets, the skeletal mesh is 67 megabytes, the texture for his feet or his teeth. It's all connected to the top-down controller. Why does my player need to know about the NPC's teeth? Absolutely don't need to know. You can see over here, stuff that it's linked to for the actual player is a lot smaller, but it's still there. And we can do the same if we come to my character here. If I do a size map on this, because I cast to the NPC, you can see it's also taking 1.7 gig. So that now means if my controller has to exist, and it has to for me to be able to play, that has to have a player pawn, which means this one has to be loaded in memory as well. And because my player pawn is casting to the NPC, that has to be in memory as well. So now we're linking these three together. This NPC might not even be in the map. It might be one of the last levels in the game. Imagine if you have a game like San Andreas and you casted to Tenpenny, the corrupt police officer. Do you really need to have access to Tenpenny throughout the entire game, every single mission? No, absolutely not. You only need to have access to it at the very last mission when you actually interact with him. So how do we go around doing this then? So this is where we come into interfaces. Interfaces are a set list of things that an actor or an object has access to. So let's take our controller here. What does it need from the character? Well, it just needs to know about its play attack function. Does it need anything else? No, nothing at all. If it does, we can add it to the list later. So let's create an interface for our character. I'm going to come to my blueprints folder. I'm going to right click and I will choose folder and I'll just call it interfaces. Inside here, I will right click blueprint interface and I will call it BPI underscore. And let's just be really specific with it because even the most specific interfaces are still better than casting in most cases. So I will call it top-down character. And let's open this up. So it's a simple interface. You have a function viewer here. You have your list of functions and you have your details. That's all you need. Zero code to create an interface. So I'm going to come to my new function up here, or I'll click add function. And the portion of code we need to give it access to is the attack. So let's just call it play attack. If you want to add any input parameters or output parameters, you can add them here. I don't need any of that. So I'm literally just going to come and click compile. Now I'm going to come back to my top-down character and I'm going to delete my play attack function because we're about to replace it. And I'll go to class settings, implemented interfaces. And I will type BPI top-down character. Now you will see down here we have an interfaces tab inside the my blueprints section. And what we're going to do is it's called implementing an interface. It's a fancy term for adding this interface and making the function available, creating the function. And all you do is double click it like that. If you can't see your interfaces, try compiling and saving and just make sure it's not collapsed. So here is our interface call here, event play attack. That's this one here. If you do have any outputs on it, you may see this, it'll create a function instead of an event. Don't worry about it. So if I come to my BPI here, if I just add an output of, I don't know, has attacked for whatever reason, hit compile and save, go back to my top-down character. If I re-implement it after I've deleted it by clicking it again, you'll see it just adds a function. It's the same thing. So now if I take this code here and move it into the play attack function, like so, and then connect this over here to the apply damage so it actually returns, because that's what we need it to do. There we go. And just make sure in any functions it always has a return point, otherwise it can get messy. There we go. Compile and save. So now it's a little bit cleaner here. It's separated away into a function, which is quite nice. So now we've added the interface to this character. Let's go back to our controller, and instead of calling play attack and instead of casting to it, we don't need to cast to it anymore. We're simply going to get the player pawn. So now we don't need to know everything about it. We know we have an interface and we want to say play attack. So I'm just going to simply type play attack. You'll see here it'll say on the interface BPI top-down character play attack message. So this is a cool part about interfaces. If this player pawn doesn't have this BPI top-down character interface, it won't do anything. It won't error. It just won't be there. However, if you need the player tag to actually return something, you can also do a simple check for does object implement interface. And if we add a branch to the end of it and connect it to true to this player tag, all this is simply going to do is confirm whether or not this actor has this interface. The interface we want to confirm is our BPI top-down code. So a little bit more code, but it just secures you enough. So you could probably put a print statement here saying you've not set your player up correct. So now that we've made that interface here, our controller now no longer has any idea what our top character has on it at all. It doesn't know about the mannequin, the camera, nothing. And let's test our size map again. If I right click and do size map, we've gone from 1.8 gig to 45 megabytes. Look at all of that memory we've just saved by simply adding a super easy interface. So you can see we could still probably optimize this a bit more, but from 1.8 gig, the optimization's pretty good. So most of this is down to my HUDs being stored. So on my player controller, you can see here I'm storing the direct HUD here. It's going to have access to all of the objects on the HUD. We don't need that. We could just store an interface or even a soft object reference, something like that. But we have successfully cleared up the controller. However, if I go back to the character, we're still casting to the NPC. So if I right click and choose size map, you'll see it's still 1.7 gig. It's still massive. So here's a little test for you, and I want you to try this if you are learning about interfaces. We need to create an interface for our NPC here that we simply can call apply damage on. That's it. So then we can stop casting here. So I want you to pause this video and just take a few minutes and see if you can figure out how to do it. Oh, that's fine. Pause the video. Okay, did you manage to crack it? Let's see if you did. There are different ways we can approach it, but this is actually a trick question. And if you did create an interface on the NPC here, which calls apply damage, that will still work fine. It'll still be a lot less memory heavy than casting this. However, the trick question here is apply damage is already technically a function built into every single actor, meaning we don't need to cast to this at all. We can just straight connect it all like that. And now you'll see we've stopped casting to our NPC from our character. If I choose size map, it's gone down to 158 meg, which is still quite big, but that's just simply because this character has to reference all the textures to make itself visible. So a little bit of a trick question there, but you can sometimes get away without using it as well. However, if you didn't have the apply damage and you were calling another function, but let's just add something here, add custom event called dance, or make them dance or something, we can't get the dance call from an actor because it doesn't exist. So let's actually create an interface. And in this time, instead of just creating one for this specific one, I'm going to think a little bit more generically about it. Do I want all of my NPCs to be able to dance? Well, most of them, yeah. And what about, like, say if we had an animal? An animal's not an NPC. They're not going to have the same functions. But we can make the interface generic so it can change. So if I create a blueprint and interface, and this time, instead of NPC, I'm just going to call it BPI dancing options. And I'm going to open it up. Inside here, I'll add my default function of dance. That's all I really need, so I'll compile and save. And then on my NPC here, I'll add the interface like we just discussed, so BPI dancing option. And we can see we now have the dance function, so I'll implement this, and I'll delete the old one off, and here I'll just put print time dancing, and then we'll hit compile. Now back on our top-down character, after we apply damage, we can just drag off, and we can use that interface. So we'll call it dance from the dancing options BPI, and I'll connect it up like so, and I'll hit compile and save. So we've added a whole new functionality now with dancing, yet if we size map it, size remains same. There's nothing massive added to it. We're not casting to it. We're literally telling our character, if you want to communicate with this actor through this interface, you will only have access to this specific function. And you can add as many as you want functions wise in here. So if I come in and add a cowboy dance, I don't know why dancing is taking part of this video, but sure, why not? Back on the NPC, I can implement cowboy dance, and I'll just make it do the same thing. Now we've got two different functions. In theory, could go and do completely different things, but back on this character, if I drag off cowboy dance, hit compile and save, it's still not affecting it at all, because all you're doing is giving it access to these completely stripped down things. That's it. You don't need to know about the character's mustache, his teeth, textures, anything. But there is another way to also use interfaces to actually get the data you want. So at the moment, we're using interfaces to tell this actor to do something. But what if I didn't want to do that and instead I wanted to get some data from the actor? Yeah, maybe if I have a variable down here called called name, and I'll set it to a type of text. And I can come here and I'll just give it a default and say his name is whatever that name at all, I think, like so. What if I want to get that actor's name from my character up here? Maybe afterwards it'll say print, hello, I've just attacked such and such. How do we get data from the NPC? So again, we can use an interface for it. So I don't really think it fits in the dancing options interface. It'd be a bit messy. So you can apply as many interfaces to your character as you want to any actor. So I'll come in and create another generic interface, but this time I'm going to call it BPI NPC. This is a very common one I use often, a generic NPC interface, and I'm going to call it Get NPC Name. And all I'm going to do is add an output of name, and I'll set it to a type offset, and I'll hit compile and save. Back on our NPC, I will add the interface, so BPI NPC. Then I will implement the interface with Get NPC Name, and you can see we now need to return what the NPC's name is. So I'll connect it up here and connect it up. Then back on our top-down character, we don't need to cast to it. There's no need. I'm going to drag off the print, and I'll just do an append, and I'll say I've just hit, and we will grab the actor, and I will say Get NPC Name. So in BPI NPC, I'll connect all this up in some funky fashion. There we go, with a little bit of tidying up, yeah. So I get the NPC's name, I append it to a print string, and I return. And now if I check the size of my character still, it's still barely anything. It is taking some bits of data up, because our interface, of course, is going to be making some connections to the NPC name, but we're talking minuscule compared to casting to it. So you can now see if I run up and I attack him, it will say, I've just hit such and such, I'm dancing, I got hit. And there we go. We are now getting data from the NPC without casting to it at all, meaning our size map stays extremely small. Now, one other good part of interfaces is I have another example here. On my dialogue here, if you check the size of this dialogue currently, it's 33 megabytes. It's absolutely tiny. So what if I say that when I talk to this professor and I say, oh, my tools need to go to the ship, I need to store a reference to that NPC to say, you know, go and visit this NPC, I don't know, do something like that. It's a common trope. So what I'll do is I'll drag off this, I'll do get all actors of class. Inside here, I will get my BP etor, I'll get the first instance of it, and I'm going to promote it to a variable, and we will call this NPC. So this means later we can use this NPC. So we're not casting to it, anywhere, but because we're storing a reference to it in memory, if I check the size of this now, you will see it's gone up to 1.6 gig. And that's because we are storing this actor in memory as a full object reference for something we're going to use. This is huge. We don't want to do that again. So we need to think, what do we actually need from this NPC? Well, I just need to get his location. So do we really need to store on the NPC, again, his mustache? No, we absolutely don't need to store that. So what can we store instead? Well, if I just need his location, I could literally just store a vector like so. It will error a little bit, but that's fine. We'll drag this off. And then from here, I will just do get world location, and we'll do it of his root point, and we'll connect it up like so. So now we're just storing the vector to his position. And you'll think that this is going to drop the size down, but in actual, it's still 1.6 gig. But why? We're not casting to it anymore. We're not, but we are directly telling it to get the actor here, which means it's got to load it into memory for you to be able to get it. So how do we go around it? Well, there are different ways we can do it. You could just come back to your NPC and use its parent class without any of this. The parent class in this case is actor. That's a basic Unreal one. I know the actor has the world location on it. If I just change it back to an actor, redo this get, because sometimes it's a bit funky, and then from here I can just drag off and choose get actor location, so it's slightly differently named. But now, instead of loading the entire NPC into memory, I'm simply loading up a dead basic actor Unreal class. I don't even know where it is on here because everything is so much bigger. It's probably going to be so small you can't even. But now you see it's massively reduced our footprint. The other option you can do is say you don't need to just get his location. Say at this specific point in dialogue, I want him to dance, because that is the key part of this video. Apparently, I don't know why. What we can do is actually run the node get all actors with interface. So what we can do is say everybody who's got the dancing interface, yeah, let's make everybody dance, not just this character. Every single one of you will now do the dance like so. And I hit compile and save. Again, we're not loading anything into memory, so it's super small footprint. We're only loading this interface, which is a minuscule amount of code. That's it. We're loading these two functions options. That's it. Compared to having to cast and know every single thing on his person, including every single one of their details as well. So if we get the mustache, because that's the thing we keep making fun of, do we really need to know about whether it's got physics enabled? No, not particularly. We don't need to know that at all. That's what casting gives you, the ability to access everything. So as you can see, it's so much easier. There we go, ladies and gentlemen. That is interfaces. I've broken them down. I've given you real world examples. I've given you some examples in the game. I've showed you how to check and how to fix it. The one thing I will leave this video with is do not get obsessed with the size map. It will drive you insane if you are trying to make every single thing the smallest amount. Do keep on top of it a little bit. But if I come to this blueprint here and do size map, it's 1.6 gig in memory to load this out. You could go insane trying to minimize that, but the end of the line is you have to take memory in the end for some things. It's just whether other things need access to it or not. That's where the key point is. Like this NPC here, he's massive because his skeletal mesh for his face is massive. There's not much you can do about that. You can reduce the quality of it, but then you're reducing quality of your game. You could reduce the size of the textures, but then you're getting less quality in your textures. You could probably do minimal things to remove it, but there will always be a finite point you can take it to before you start losing access to things. That's it. So that's interfaces. Super easy to do. Thank you for watching, ladies and gentlemen. I hope this helped. If it did help, please leave a like and a comment. A subscription would also be nice because I release videos every single week, every Thursday. Thank you for watching. If you do find any massive blueprints in your game and the size is quite funny, feel free to share it. I've seen some with some clients where their characters are 16 gig because they're casting to every single line. And if you do resolve some of these bigger ones, you can gain a lot of frames back, making your game better, giving you the ability to add more. Thank you for watching, ladies and gentlemen. My name is Decryption and I will see you next time.